Hello guys, welcome to Ramta Solutions and welcome to your grade 12 trigonometry. Today we're looking at compound angles. So in your compound angles, or rather at the end of this video, you will be able to use these formulae, okay? You will be able to use these formulae, and not only that, you will also be able to derive them. All of these, okay? So stay tuned and enjoy this lesson. So how this video is going to go about, we will introduce to you why you're doing compound angles. And then from then, we will derive these guys, compound angles of cosine, sine, and then conclude by having examples. There will be plenty of examples in this video because we want it to be a video where you can get all the things that you want for your grade 12 trigonometry. Okay. All right. So let's begin now with our introduction. So as introduction, can you now, I want you to do this. Can you solve 75 degrees? Can you rather evaluate 75 degrees without a calculator? Cos 75 degrees without using a calculator. Can you do that? Remember, when you get such a question, a lot of times you must ask yourself if you can have special angles, right? Because by now you know you can calculate special angles without using a calculator. So I think so far you cannot, but at the end of the video, you will be able to. Because even if you want to break this into special angles, this could be 60 plus 10, 10 is not, 65 plus 10, they are not special angles. But can you get 60 plus 15? It is not, 15 is not a special angle. 30 plus 45, perfect. All right, so this 75 degrees can be 45 degrees plus 30. But now I have to ask you a question. You have cos 75 degrees, which we say is 45 degrees, 45 degrees plus 30. You agree with me that when you have this, you have not, in fact, your whole life come across such a thing. I know there are those who will be tempted to say, FOIL method, cos 45 plus cos 30. That's not true. Okay? So, using your calculator, let's find out what is cos 75. Your calculator gives you root 6 minus root 2 all over 4. Right? All over 4. Okay? So now you will be able to get this value here by using this expression in this way. Okay? Remember guys, cos 45 degrees plus 30 is not cos 45 degrees plus cos 30 degrees. That's very wrong. Okay? So now you will be able to use compound angles. Now stay tuned. This will be a long video, but it will be worth it. Let's go. Now, let's then derive. We are now deriving cos alpha minus beta. Let me look for a circle. Let me look for a circle. Okay, let me use the circle here. Okay. Okay, I'm going to use this circle here. Then, okay, let me move it a bit. Then, I'm going to say, let me draw, I want to draw a Cartesian plane inside it. Okay, using the yellow inside the white is not conducive. Let me try a red. Okay, Yeah, it's clearer now. Okay. We are assuming that this is the center, okay? We are assuming that this is the center. So yeah. Okay. So now let's then say we have a point somewhere here. Let's call it whatever point. And then we have another one somewhere there. Okay. So we say we have a unit circle. Okay. So when we say a unit circle, we mean the length is 1. As you know, I have to change the color. The length is 1. Again, the length is 1. Let me put this one here. The length is 1. So I'm going to call this point here point P with coordinates A, B, and then I'm going to have a point here which I call point Q with coordinates D, E. Okay? Now, I'm going to call this angle here alpha, whereas I will call this one here beta. Then I'm going to call this angle here, as you can see, from here to here it's alpha, from here to here it's beta. So obviously this portion will be alpha minus beta. Okay, this portion will be alpha minus beta. Let me do this. This portion will be alpha minus beta. Okay, so what we need right now, we want to determine PQ. Okay, we want to determine PQ, or let's try to find the distance PQ. Okay, to find the distance PQ is easy, but we are not really there. The intention is to basically derive cos alpha minus beta, but we can use that using cosine rule and area rule. Sorry, cosine rule and distance formula. Okay, so now using distance PQ, let me say that using PQ, 1, using cosine rule, okay, using cosine rule, we're going to say, from cosine rule, we know, remember guys, we have this angle here, and we're looking for PQ. We know cosine rule. What does it say? Cosine rule was saying to us, a squared equals b squared plus c squared minus 2bc cos angle A, right? That was cosine rule, okay? That was cosine rule. So what it's saying is that A is opposite angle A, and then how we use cosine rule is that it must be when we have two sides and an included angle. And when you look at it, we have it here. Remember, this is center of the circle, right? This is center of the circle. Now, since this is center of the circle, the radius to the the line from the center to the circumference is the same throughout the circle, right? So OP is also equal to OQ because they are the radii, right? Okay, so now let's come back to this. If we look for PQ, maybe let's try with PQ squared. Let's see, because you're looking for PQ. So I'm just going to say PQ squared is equal to what? OP squared plus OQ squared minus 2 times OP times OQ times cos angle POQ, right? Cos angle POQ, isn't it? Now, what is PQ? So far, we do not know what is PQ. So we're going to leave it as PQ squared. What is OP? This was a unit circle. As you can see, it means the distance OP is 1 unit. What is OQ? Again, it's still 1 unit minus 2 into 1 multiplied by cos what is angle POQ? Angle POQ, you guys have seen it. Here is it. Angle POQ is alpha minus beta. Alright, it's alpha minus beta. Let's write it. Alpha minus beta. Alright, cool. So further simplification, we have PQ squared equals 1 plus 1 minus 2 cos alpha minus beta. Therefore, PQ squared equals 1, or 2, not 1. 1 plus 1 is 2, so 2 minus 2 cos alpha minus beta. Alright? Okay. Cool. Moving on. Now, we are going to use distance formula. Okay? So, using distance formula, we know PQ squared is equal to x of q minus x of p all squared plus y of q minus y of p all squared. So, distance formula comes from this. If you recall, maybe you get confused here. You know your distance formula is AB equals square root of x of b minus x of a all squared plus x of what? Y of b minus y of a all squared. Alright? So because you are now in grade 12, in grade 11, you learned about sets. Alright? So what do we mean? I mean, let me rewrite what's under the square root. Close it. Remember, a set, especially a square root, means you have power half. Now, to kill a power, you need to multiply by its inverse. So, you multiply throughout by the inverse. Therefore, you will be having AB squared is x of b minus x of a all square plus y of b minus y of a all square. Can you guys see that? Perfect. Okay. Now, I want you guys to see something here. I'm going to just draw. You now have an idea of how this thing looks like. I'm going to redraw this thing without really using the circle. Okay? I want to show you something. So we say, okay, let me go back to my yellow. So we saying, should I? Okay, no, let me not. Okay, I taught you guys in the reduction formula, I taught you that you can rewrite such angles in acute form, right? Your angle alpha can be written in an acute form. So basically what I'm saying is what you had, okay, I have to rewrite this. I'm just gonna draw this and then this. Okay, I'm just gonna make it. Okay, yeah, let me just do it. Okay, all right. Now you had P with A and B, and then you had Q with D and E. So this was alpha, while this one here was beta. So we can also say this one here, note going upwards, is alpha. Okay, it's alpha. Okay, so now as you can see, we have, now pay attention, we have, let's now focus on D. On D we can say, remember that length was 1 unit, we can say, like cos, let me begin with alpha. Cos alpha equals, what is the value of x? The value of x is A What is the hypotenuse? It's 1. Remember, cosine is adjacent over hypotenuse, right? So what is this? This implies A equals cos alpha. Now let's look at sine alpha. What is sine alpha? Sine is opposite over hypotenuse. Remember, cosine is adjacent over hypotenuse. Now sine is opposite. What is opposite? This refers to the y value. What is the y value? It's p. What is the hypotenuse? It's 1. Therefore, this implies b equals sine alpha. Okay, let's then come to beta. Now, cos beta is adjacent over hypotenuse. Adjacent refers to the value of x. What is it? It's d. What is the hypotenuse? We said it's 1, implying d equals cos beta. Similarly, sine beta will be e over 1, implying that e is equal to sine beta. Therefore, point P has coordinates cos alpha sine alpha, and point Q has coordinates cos beta and sine beta. Okay, you can see now we are looking for Q of P and X of P. X of Q and P of Q, Y of Q and Y of P. Okay, so we will substitute all these. We will substitute these now into our PQ. Okay, going on. So now say, let me rewrite that. PQ square, remember, was equal to X of Q minus X of P all square plus Y of Q minus Y of P all square. So, because you are seeing PQ square, maybe let me not substitute it as yet. We have seen it somewhere, right? But for now, I'm going to leave it as it is. Maybe I will call it equation 1. Let's call it equation 1. Okay. All right. So we continue with PQ. PQ equals, what is X of Q? X of Q was cos, which one is it? X of Q is this one here, the X value, which is cos beta. Okay, so it was cos beta. What is X of P? X of P is cos alpha minus cos alpha all square. And then Y of P must have been sine beta. Let me confirm. Yes, sine beta. And Y of P is sine alpha. Okay, minus sine alpha all square. Now let's try to simplify these. Expanding this, we have cos square beta minus 2 cos beta sine alpha plus cos square alpha. We're done with this. This is the FOIL method. Expanding on this, we will have plus sine square beta minus 2 sine beta, 2 sine, oh boy, I made a mistake here. I see it. There's no way that I can get sine. It was sine cos. My mistake. It's cos, right? So here it'll be sine beta sine alpha plus sine square alpha. Okay, continuing, P square. To those who are confused, let me write this quickly. Cos beta minus cos alpha, remember it's all square. It's similar to saying this multiplied by itself. So you're using the FOIL method. Okay, using the FOIL method. Okay, this is what you get when you use the FOIL method. Okay, perfect. So, continuing, I want to somehow relate those that can be related. I do see we have cos, okay, go back to yellow. We have cos square beta. I see another sine squared beta. Sine squared beta. I see cos square alpha. There's also sine square alpha minus 2 cos beta sine alpha minus 2 sine beta sine alpha. Okay, again, we're saying PQ square is equal to, I want you now to look at this. This is a square identity. Cos square plus sine square of the same angle is 1. Or similarly, we can say the same about this one. So this is 1 plus 1 minus 2 cos beta sine alpha minus 2 sine beta sine, oh boy, I made that mistake again. I don't know why I keep making this mistake. It's it's cos beta, so it's cos beta, cos alpha. Here is it. It's okay. I don't know why I keep making this mistake, but I think it's, yeah. And luckily I get reminded when I get to sine. So it's cos beta cos alpha minus 2 sine beta sine alpha. Again, PQ square equals 2 minus 2 cos beta cos alpha. I got it this time. Minus 2 sine beta sine alpha. I'm going to call this equation 2. However, there was no need for me to call it equation 2 because I could see from the previous that this was PQ square. Right? From equation 1, this was PQ square. So in other words, maybe let me say it to you, PQ of equation 1, PQ square of equation 1 is equal to, of course, PQ square of equation 2. So what I'm trying to say, we're going to fetch equation 1. Okay, what is equation 1? Or is it? It's 2 minus 2 cos, open bracket, 2 minus 2 cos, open bracket, alpha minus beta. Now, what is that of equation 2? It was 2 minus 2 cos beta sine, never, not again, cos alpha minus 2 sine beta sine alpha. Can you see that? Perfect. All right, yes, it is 2 minus 2 cos beta cos alpha minus 2 sine beta sine alpha. Can you guys see that? Cool. So, as you can see, this 2 will cancel with the other 2. So we are left with minus 2 cos alpha minus beta is equal to minus 2 cos beta cos alpha. Yes, I got it this time. Minus 2 sine beta sine alpha. Now, dividing by negative 2 throughout, we will be left with cos alpha minus beta, which will be negative divided by negative. It's positive. Cos beta sine cos beta cos alpha. Again, I'm still dividing by negative 2. It's going to be plus sine beta cos, oh man, sine beta sine alpha. Okay, so this is you now deriving that formula. Let's go to the first page. We have cos alpha minus beta is equal to cos beta cos alpha plus sine beta sine alpha. Right? So this is just any arbitrary angle. So this is just whatever symbol you use to represent whatever angle. It can be a minus b, like in the opening slide, I think. Let me go there. Yes, in the opening slide, it was A minus B, but we are working with alpha minus beta. Can you see that? It can be D minus C. It can be anything, okay? As long as it's written in this form, it will be like this, okay? Perfect. Okay, so we were able to prove, let me now write it in bold letters. We were able to prove that cos alpha minus beta is equal to cos beta cos alpha plus sine beta sine alpha. This is an important formula. Okay? Cool. Now, we're heading to the second derivation. Now here we are deriving cos alpha plus beta. Now with this one, we're continuing with what we had in the first derivative. So we will say, given cos alpha minus beta, given cos alpha minus beta equals, I think we said it was cos alpha, cos beta. Did we say that? Yes. Oh, by the way, the order does not matter, guys, okay? The order does not matter. Okay. Whether it's cos before, it's beta before alpha, it does not matter. Remember, 3 times 5 is similar to 5 times 3, isn't it? Perfect. So, cos alpha, cos beta, plus sine alpha, sine beta, determine cos alpha plus beta. Now our solution, we will say cos alpha plus beta is equal to cos, check this out. Remember, we are given this guy here, cos alpha minus beta. Okay? So if we have alpha plus beta, can't we say this seems like alpha minus, open bracket, minus beta close. Can't we say that? We can, right? I mean, check this out, guys. We're saying alpha plus beta is equal to alpha minus beta. Negative times negative is positive, so it's okay. Can you guys see that? Perfect. Proceeding. Now we have, as you can see, this is what you had initially. In the middle of another angle, there was a separation of a negative or a minus, so it's perfect. So check this out. This is angle 1, this is angle 2. Okay, so we have cos alpha, cos, pay attention, this is no longer angle beta, it's angle negative beta, plus sine alpha, sine negative beta. Now, negative angle of cosine will always be positive. All right? So it becomes cos beta plus sine alpha, negative angle of sine. Oh boy, it must be negative sine beta. Therefore, we have cos alpha, cos beta minus negative times positive, so it's minus sine alpha, sine beta. Okay, therefore, what can we say? We can say cos alpha plus beta is cos alpha, cos beta minus sine alpha, sine beta. Can you guys see that? Remember, again, that cos alpha minus beta was cos alpha cos beta plus sine alpha sine beta. So for compound angles of cosine, if it's cos whatever angle plus another, that formula will have a minus. If it's plus, it'll have a, if it's minus, it'll have a plus in between. If it's plus, it'll have a minus in between. Can you guys see that? Pay attention to this. It'll be of great use later. Okay, so this was number 3, not number 2, it was number 3. Okay, then let's go to number 4. Did we say we're deriving? Okay, sine alpha minus beta, it's okay. Now, deriving sine alpha minus beta. Again, now you have two formulae that you can use. You can use cos theta alpha plus beta or cos alpha minus beta. However, I will choose one of alpha minus because yeah, I will choose that one. So I will say, given cos alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta, determine sine alpha minus beta. Okay, all right, cool. So we will say sine alpha minus beta. That's our solution, by the way. Solution, I will say sine alpha minus beta. Remember, we are given a relationship of cosine and we must find sine. Remember, sine and cosine are cofunctions. So, this is interesting. This must have been cos 90 degrees minus, open bracket, alpha minus beta, isn't it? It must have been something like this. Okay, as you can see, if you have cos 90 minus alpha minus beta, you will be having sine alpha minus beta. Okay, this is because cosine is a cofunction of sine. Proceeding, we have cos 90 degrees minus alpha plus beta. Okay, 90 degrees minus alpha plus beta. Okay, it does not matter. If you like, you can say it in this way. You can say you have cos 90 degrees plus beta in a bracket like this and say minus alpha. It's okay. Remember here, these are just arbitrary angles. What I mean is, you can change them to whatever. You can call them angle Z, angle K, doesn't matter. Angle A or angle B doesn't matter. Okay, you can do it in this way, or you can do it in this way. You can say, as you can see, you have 90 degrees minus alpha plus beta. It can be 90 degrees, or open bracket, 90 degrees minus alpha plus beta. And therefore proceed to say 90 degrees minus alpha close minus beta. Can you guys see that? Whichever you prefer, guys, is okay. Whichever you prefer is okay. Whether you prefer to use this one or use this one, it's okay. Eventually, it leads to giving you the same answer. Okay. So I think I will go with this one. Okay, I will go with this one since it's easier to work with, because now you can see the form says you must have an angle and then two angles. There must be a minus in between the two angles. One angle is 90 plus beta, another is theta. Can you see that? There's a minus in between it. So let's take it. Let's proceed with this one. If you like, you can go with this one. Whichever you like, it's okay. I will go with this one. So let's go. So this is compound angle of of cosine. So what was it? It was cos 90 degrees plus beta and cos alpha. Remember? And because it's a minus, it will become a plus. Sine 90 degrees plus, 90 degrees. 90 degrees plus beta multiplied by sine alpha, right? Oh, now I see reduction formula. So in the 90 plus quadrant, cosine is negative. Do you guys agree with me? In the 90 degrees plus quadrant, let me remind you the cast diagram. We had 90 degrees plus, 90 degrees minus, 90 degrees plus, or this one was 180 degrees minus, right? And this one was 180 degrees plus, this one was 360 degrees minus. Obviously, we said all students take coffee. All students take coffee, right? Perfect. Now, cosine in the 90 plus is negative. Okay, so proceeding. Cosine in the negative plus quadrant is negative. So it'll be, hold on, this is 90 degrees. So cosine will change to sine. So it'll be negative sine beta. And then what do we have? Cos alpha, we leave it as it is. Cos alpha, we leave it as it is. Sine in the 90 plus, where's the 90 plus? It's the second quadrant. It's positive. But because it's 90 degrees, sine must change to cosine. So it'll be cos beta. It'll be cos beta. And of course, we're left with sine alpha. So it'll be like this. So what do we have? We have sine beta cos alpha, right? Plus cos beta sine alpha. Remember, guys, I had said to you 2 times, I used 3. Let me not say I have said. Now I'll be lying if I do another number. 3 times 5 is 15. 5 times 3 is also 15. Okay, so if you like, you can rearrange these and say, okay, you have cos, maybe let me say sine. I'm going to rearrange them, or cos beta sine alpha minus sine beta cos alpha. Can you guys see that? If you like, it's just aesthetics and nothing much. Sine alpha cos beta minus cos alpha sine beta. Can you see that? So what we are trying to say, we are trying to say that sine, this is too big, I don't like it. Sine alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. This is an important formula. Okay? This is an important formula. Remember what I have said here, guys. I said it's just preference. And why I decided to rearrange is because we worked with alpha minus beta. So I want you to think, alpha comes first, but it's basically the same thing. Okay? However, it's better in that way. Okay? It's better in that way. And if you have used it, if you have done it in this way, this is where you're gonna get it perfectly. So whichever you do is okay. Maybe let me do it in this way. Should I? No, we don't have to. It's okay. If you can do it in this way, it'll also be okay. Okay. This is when you get it exactly like this. But these are the same. Okay. All right. Then let's head to number 5. Number 5. Number 5, we are deriving sine alpha plus beta. So again, given cos alpha minus beta equals cos alpha cos beta, yay, I got it, equals sine alpha sine beta, determine, I think I should say determine determine sine alpha plus beta. Okay, now our solution will say we are looking for sine alpha plus beta. Now this one, because we have already derived what is this? We have already derived alpha minus beta. It might be tempting to say we're supposed to say you're supposed to use the alpha minus beta, and I'm going to show you why I'm saying that. So what if we say this is sine alpha minus beta, right? Do you guys see that? Because we derived this one here. Might be tempting to say, let me use that one. This question did not begin with you are given sine alpha minus beta. It says you are given cos alpha minus beta. So it means we must come to this point where we use this guy. We move from this guy to this guy. Okay, let's see. So we say this must somehow have been 90 degrees minus alpha minus negative beta, close again. All right? Okay. So what do we have? This is interesting. All right? This is interesting. And with it being interesting, I just want to say I'm going to return it to what it used to be. Okay, I'm going to return it to what it used to be. So I'm not going to continue with this. I'm just going to say, yes, let's just simply say it's cos 90 degrees minus alpha plus beta. Okay, now what is this? This is cos 90 degrees minus alpha minus beta. If you like, this could be 90 degrees minus alpha, you can group it, minus beta, you can leave it out. All right? So this is now okay. Even the previous method was also okay, but I prefer to go this route. Okay. All right. Now we have cos 90 degrees minus alpha cos beta. Remember, oh, my mistake. This is supposed to be plus. It's supposed to be plus. So cos 90 minus alpha and cos beta plus sine 90 degrees minus alpha and then sine beta. Going back to that cast diagram, 90 degrees minus quadrant, it's the first quadrant. All ratios are positive. So in the first quadrant, cosine is positive, but because this is 90, cosine changes to sine. It'll then become sine alpha. We have cos alpha. Again, in the 90 minus quadrant, all ratios are positive. Sine is also positive. In other words, I said all ratios. So because it's a 90 degrees, sine changes to cosine. Okay, so it's plus cos, oh boy, I made a mistake. Beta. It should be a beta. It should be a beta. So, okay, so this will now be cos alpha. It'll be cos alpha times sine beta times sine beta. Can you guys now see it? So in other words, sine alpha plus beta is equal to sine alpha cos beta plus plus cos alpha sine beta. If you recall, sine alpha minus beta was sine alpha cos beta minus cos alpha sine beta. Now, this one, the ones of sine are different to that one of, the ones of sine are different to that one of cosine. Remember, with that one of cosine, when it's alpha plus beta, inside it, it'll be cos and sine, but they will be separated by an opposite sign, right? For cosine, it'll be cos, sine, but they separated by an opposite sign to what's inside the bracket, right? But with sine, it's sine cos, but the in between, it'll be similar operators. If it's plus, it'll be plus. If it's minus, it is minus. Okay? All right. Perfect. Now, we have now summarized this. Let's perhaps summarize this. So, in summary, we will say cos alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta. Cos alpha plus beta will be cos alpha cos beta minus sine alpha sine beta. Okay, now sine alpha minus beta will be sine alpha cos beta minus cos alpha sine beta. Okay? And then sine alpha plus beta will be sine alpha cos alpha minus, plus cos alpha sine beta. So these are your compound angles. Let me go to the third one. I want to confirm something. The third one. Okay. Okay, it was the fourth. Okay, cool. All right. Yes. So this is our summary, and these are the formulae that you're going to use. Okay. We now head to examples. There will be plenty of examples. Okay, there will be plenty of examples. Now let's get into it. Now, I'm going to call this one EG1. EG1, remember, the opening example, evaluate cos 75 degrees without using a calculator. Without using a calculator. So, what is our answer? We have cos 75 degrees. We can say, basically 75 degrees, like we said in the opening slide. When they say without using a calculator, we need to think of special angles. It will be cos 45 degrees plus 30. Now, what is this? This is cos, but with a plus and a plus. So, with a plus. So this means we will say cos 45 degrees, cos 30 degrees, minus sine 45 degrees, sine 30 degrees. Okay, because I know these guys, but let me just not do that. For those who might be watching our videos for the very first time, when we get to special angles, we have a special way of finding them. Okay, you write these two, you draw these two lines, then inside these two lines you draw three lines. Line 1, line 2, line 3. You recall, this one is the 30 degrees, this one is the 45 degrees, this one is the 60 degrees. Okay, then you start counting from here. You say this is 0, 1, 2, 3, 4. Don't forget to put semicolons. And then you start from the bottom line. Say 0, 1, 2, 3, 4. And then do not forget to write 2 here and put square roots. Square root, I can put square root on 4. I should. Square root on 3, on 2, on 2, on 3, again on 4. The reason I don't put, basically I'm saying put square root in all these values here. Okay? But I don't have to put a square root on 0. It's 0. Square root on 1 is 1. I don't have to put a square root on that. This is why I'm leaving it. Okay? So when I want cos, let me say cos 45 degrees. When I want cos 45 degrees, and by the way, before that, this is xy. In other words, it's adjacent and opposite. Okay? It's adjacent and opposite. Cos 45. You go to the 45 degree line. This is 0 degrees, 30 degrees, 45, 60, 90. So you want 45 degrees. You go to 45 degrees. What is cosine? Cosine is adjacent over hypotenuse. This is the hypotenuse. This value here is the hypotenuse. So what is 45? Its adjacent is root 2. What is hypotenuse? It's 2. Okay. Let me now take cos 60 as an example. Sine 60 degrees. Let me take sine. Sine 60 degrees. What is sine? Sine is opposite over hypotenuse. What is opposite? It's root 3. What is hypotenuse? It's 2. If you press these on a calculator, you will, if you press cos 45, you will get root 2 over 2. Similarly, if you press sine 60, you will get root 3 over 2. Now, when you try tan 60 degrees, tan is root 3, which is opposite over adjacent, 3. But if you try tan 30 without using a calculator, you get 1 over root 3. Let me check what the calculator returns. But you don't end here. You say it's 1 over root 3, you multiply by root 3 over root 3. This we call rationalizing the denominator. And this must be root 3 over 3. I don't know what your calculator returns. Let me check quickly. Tan 30 degrees. It's root 3 over 3. So you won't be penalized for leaving it like this or even just 1 over root 3. Why? It's important to rationalize your denominator unless they have stated otherwise. Okay. All right. So let's proceed. So cos 45 is root 2 over 2. Cos 30 is root 3 over 2 minus sine 45 is root 2 over 2. Sine 30 is half. So these are the things that you should know, guys. If you do not know them, you can use this diagram. It will help you a great deal, okay? Perfect. Now, as you can see, we say numerator times numerator. Root 3 times root 2 will be root 6 over 4. And then root 2 times 1 is simply root 2. 2 times 2 is 4. Therefore, what is our answer? Our answer is simply root 6 minus root 2 all over 4. I'm going back to that example that we had in the first page. Sorry, in the introduction slide. This is it, guys. Can you see it? This is it. So this is how you do your compound angles. Do you see that it has given you this answer without using a calculator? Okay. So I'm happy you guys now have an idea of how we go about this. Now, let's then have plenty of examples. This will be interesting. It will be a very long video, but bear with me, guys. Okay, example 2. What should we say? We will say evaluate, number 1, cos 110 degrees, cos 20 degrees, plus sine 110 degrees, sine 20 degrees. Number 2, sine 13 degrees, cos 32 degrees, plus cos 13 degrees, sine 32 degrees. Proceeding. Third one is, let's try sine 300. Sine 300 degrees. Okay, sine 300 degrees. And then we will also try number 4. Let me try cos 15 degrees. Okay, cos 15 degrees. Okay, all right. Now let's get into it. Number 1, we have cos 110 degrees, cos 20 degrees, plus sine 110 degrees, sine 20 degrees. As you can see, this is cos. It must be compound angle of cosine. In the middle, it has an operator plus. So this means it must be 110 degrees minus 20. Okay. Now what is 110 degrees minus 20? It's 90 degrees. All right? It's 90 degrees. Okay, I repeat, cos, but inside, between cos and sine, you have a plus. This means you will have cos 110 degrees minus 20. Okay, now this is cos 90, and your answer is simply 0. Okay, you can also press this on your calculator. Your calculator will return 0. Okay, perfect. Now, then try, let's go number 2. Number 2 was sine 13 degrees, cos 32 degrees, plus cos 13 degrees, sine 32 degrees. So this is sine cos, and in the middle there is a plus, so it will be sine 13 plus what? Sine 13 plus 32 degrees. So 13 plus 32 is 45 degrees. Therefore, if you are not sure, this is root 2 over 2. If you are not sure, you can use that diagram, okay? Or directly, you can substitute on your calculator. You can press this on your calculator, okay? Sine 45 is root 2 over 2, okay? Perfect. Now, number 3. Number 3, what was number 3? Let me confirm here. Sine 300. Okay, it was sine 300. Now, sine 300. Sine 300. Now, 300, what we know, 300, we now use a reduction formula. 300 is in the 360 minus quadrant. All right? So 360 minus 300 will be 60. In other words, this is 360 minus 60. If you say 360 minus 60, you get this 300. All right? Okay, so it's totally up to you as to how you use this, but for the sake of this video, we will use compound angles. We will say this is sine 360 degrees. It's tempting to use a reduction formula. It's okay as well. But for the sake of this video, we're using compound angles. Sine 60 degrees cos, sine 360 degrees cos 60 degrees. Because it's sine, it will be minus cos 360 degrees sine 60 degrees. Now, sine 360 degrees is 0. Cos 60 degrees is half. Okay? Minus cos 360 degrees is 1. Sine 60 degrees is root 3 over 2. Proceeding. 0 minus root 3 over 2. Our answer is simply root 3 over 2. You can press sine 300 degrees on your calculator. You will be getting root 3 over 2. Okay. Now, remember what I have said, guys. Now you are in grade 12. You can use reduction formula or you can use compound angles, whichever you prefer. Unless if the exam tells you to use compound angles. But when you get to such questions, it's totally up to you. The one that's convenient for you, you choose it. But of course, for the purpose of this video, we are using this one here. We are continuing with it as compound angle. Okay, perfect. What is number 4? Cos 15 degrees. Cos 15 degrees. Now, this must be 45 minus 15, right? Again, it's cos, so it must be cos, but plus because it's a minus here. It's cos 45 degrees. Oh, no. What am I saying? It's cos 45 minus 30. Okay, 15 is 45 minus 30 or 60 minus 45, whichever you prefer. However, I like 45 minus 30. So this is cos 45 degrees, cos 30 degrees. But because it's minus, it will be plus sine 45 degrees, sine 30 degrees. Cos 45 is root 2 over 2. Sine cos 30 is root 3 over 2. Again, sine 45 is root 2 over 2. Sine 30 is half. This is root 6 over 4. And this is root 2, square root of 2 over 4. Therefore, our answer is simply square root of 6 plus square root of 2 all over 4. That is our answer. Okay, that is our answer. Now, let's try one last example. Okay, let's try one last example. Now, what example number is this? Example 3. Okay, now example 3, I will say prove YZ. Okay, prove sine 60 degrees minus x plus sine 60 degrees plus x equals square root of 3 cos x. Now, which one can be easily broken down? It's the left-hand side, right? It's the left-hand side. So our solution, because we are proving, left-hand side equals sine 60 degrees minus x plus sine 60 degrees plus x. Let's see. It's sine, so it's compound angle, as you can see, different angles. So it will be a compound angle. But for sine, it will be sine cos, sine 60 degrees cos x. But because it's a minus, it will also be a minus. Cos 60 degrees sine x, right? Plus 60 degrees plus x. It'll be sine 60 degrees cos x. It's a plus, so it will also be a plus. Plus cos 60 degrees sine x. As you can see, cos 60s are cancelling. Can you guys see that? The cos 60s and x are cancelling. We are left with 2 sine 60 degrees cos x. Okay, they are like terms. As you can see, sine 60 degrees cos x plus another sine 60 degrees cos x. However, the negative cos 60 degrees sine x plus cos 60 degrees sine x will cancel, meaning they will become 0. So we're not going to consider that. Now, what we know, sine 60 degrees is root 3 or square root of 3 over 2, of course, multiplied by cos x here. Now the 2's are cancelling. We are left with square root of 3 cos x, which is equal to the right-hand side. Okay, which is equal to the right-hand side. So this is your compound angles. Let me go back to the opening slide. Okay. In the opening slide, I promised you that you will be deriving these formulae and you will be applying them. So you have seen how to derive them, and now you have also seen how to apply them. So we have fulfilled our mandate, our promise. We fulfilled it. So it's fulfilled. Now, I think we can call it a wrap and say, if you have come this far, you watched this video until this point, you deserve all the great marks that you will be getting in your exams. Okay. I hope these videos are a great deal. So with that being said, please, before you go, do not forget to subscribe, to share with your friends, your classmates, and all the best. So, bye-bye.